All right, hi guys. I'm back for a new term. Hopefully you had a good holiday and you're enjoying being in the ISO life. Anyway, we'll get started. So hopefully you remember at the end of last term we were looking at inequalities. We're going to keep looking at that for the first week, and then we're going to go on to probability probably next week. Okay, so far what we're going to look at today is where we've got multiple inequalities. Okay, so where you've got two lots of inequalities in the same equation. But we're going to start off just with a bit of revision. So hopefully you remember from last time, say if we're solving an equation like this one, 3x plus 1 is greater than 7, we're looking for what values of x make this true. So where is 3x plus 1 bigger than 7? Now, just so you know, that's obviously your title, there's your date. I'm not going to send this to you today because it's only 3 examples that you need to copy down. So I don't think you really need printed notes, but when we get up to the stage where you will need printed notes, then I'll send them through to you. This bit in red, this is just revision, so you don't need to copy that down. Once we start going through these ones, then you should probably start copying them down. Okay, so where is 3x plus 1 greater than 7? So same again, we solve this like a regular equation. We're going to take away 1 from there, 3x. That means 7 minus 1 is 6, so 3x is greater than 6. Then we divide through by 3, cancel that out, so x is greater than 2. Okay, now I want to show you what this will look like on a graph, because I think that will help for where we've got the two inequalities. So if we look at, obviously we know that this should be a straight line graph, right, like a linear equation, because you've got that form of mx plus c. Okay, you've got something times by x and then you're adding on a constant. So we're expecting a straight line graph. The gradient's positive, so we are expecting it should go up like that. Okay, and I'll show you that on your graph looks like this. Okay, so there's your 3x plus 1. Right, we can see that we've got a y-intercept at 1 and the gradient's 3. Now, if we find where is 7, because our equation was 3x plus 1 is greater than 7. So if we find where 7 is, that's around about, I'll just put a point on, okay, that is at here, okay, so that's at where the y value, where your equation is equal to 7, okay, so between 6 and 8, that's where it's 7. And we can see that corresponds to 2, and our solution here when we were solving the inequality was x is greater than 2. So we can see here that for any value that's bigger than 2, okay, your answer is bigger than 7. So that's correct for that inequality there. And if I show you what this looks like, you can actually put this into a graphing calculator. And if I show you, I've got it here, you can see it on the side there. So we got 3x plus 1 is greater than 7. So if I show you what that looks like, it comes up as this big kind of rectangle thing. So you can see that vertical line there, that goes through 2. And then it shades in everything that's greater than 2, because that's where that makes that true. Okay, now when we look at what we're going to go on to today, which is where we've got multiple inequalities. So if I turn on this one here, this is where 5x minus 2, where is that? Greater than 8 and less than or equal to 23. Now when I turn this on, you can see here, this doesn't keep going on forever like that other one did. It doesn't keep on going up and up and up and up and up till infinity. It's got two defined values because we're finding where is x less than 8 and greater than or equal to 23. And we can see here that x should be greater than 8 when x is greater than 2, okay, because we've got that chopped line through 2, and that chopped line means it's not equal to, okay, so where it's not equal to 2, so anything bigger than 2, but anything smaller than, that's between 4 and 6, so I'm going to say that's 5 there, okay, so anything smaller than 5, so that's the answers that we should get, and I'm going to show you how to solve that algebraically as well. But you might want to use GeoGebra as you're doing this, and you might want to actually graph it and see what kind of answers you're getting, okay. So from here, when you're solving multiple inequalities, we pretty much solve it in a similar way as we did the last ones, except what you're going to do is you're going to split it up into two equations, okay. So we take this 8 and we copy that down first, okay, and then we keep the inequality sign the same, and then we've got 5x minus 2. So that's where 8 is less than 5x minus 2. Then we look at the other side, and we've got 5x minus 2 less than or equal to 23. Okay, so we just split it up into two separate equations. Right, now we can solve both of them. So if I solve this one first, okay, we're going to add 2 to this side, cancel that out. So we're left with 10 is greater than 5x. Okay, we then divide by 5, cancel that out. So we're left with 10 divided by 5 is 2. Okay, so we've got there x is greater than 2. Then on this side, we're going to add 2 to that 23. So we've got 5x less than or equal to 25. Then again, we divide through by 5 again. And we're left with x is less than or equal to 5. Okay, so our whole solution now, we put this together. Okay, the x goes in the middle. X is greater than 2. Okay, exactly the same way as it's presented there. And x is less than or equal to 5. Okay, so we just put those two x's together, and then the inequalities kind of naturally follow the same way as they did before. Okay, and that's our solution, and we can see that that's the same as what you had in that graph. Okay, greater than 2 and less than or equal to 5. All right, and that makes that rectangle there. Okay, perfect. All right, if you want, for the next two examples, pause the recording, have a go at them yourselves, and then listen to the answers. If you're not feeling that confident, maybe listen to the next one and then try the third one yourself. Or if you're still feeling really stuck, listen to both of them. But I think it's always best if you learn from your own mistakes. So I would prefer that you do it yourself, get it wrong, and then listen to me do it, rather than just listen to me and probably not take it in as well. Okay, so if you want to, pause it now, have a go of it yourself. If not, keep listening and I'll do the answers. Okay, so this next one, exactly the same thing. We've got 2x plus 3, and where that's greater than 1 and less than 5. So we're going to split it up into the two equations. So we bring the 1 down, we keep everything else exactly the same, we just leave off that less than 5. Then we do the same thing with the other side, but we leave off the greater than 1. So we've got 2x plus 3 less than 5. Okay, cool. So if we do with the left-hand side one first, okay, we're going to minus 3. Now, 1 minus 3 is negative 2. Okay, 2x. We divide through by 2. Okay, so we end up with negative 1 is less than x. Now, just remembering as well, if that was a negative 2, we would have to flip that sign around. But because it's not a negative 2, it's a positive 2 you're dividing by, you keep it the same. Right? Now, on the other side, we've got 2x plus 3. So we're going to minus 3 again from that 5. Cancel that out. So 2x is greater than 2, is less than 2, sorry. And then we divide by 2 again. We end up with x is less than 1. Okay, so now we put it all together. We put x in the middle. Okay, we've got a negative 1 on that side and the left-hand side. And then we take this bit, this positive bit, and we chuck that on the end. Okay, so x should be between negative 1 and positive 1. Okay, that's our solution. All right, third one. 2x and then negative x and 4. Okay, now this one's got a negative x. Remember that flipping that I was just talking about before? That's when this is going to come into play a little bit. Okay, so in this case, we would take, again, the left-hand side. So we've got negative 2 less than negative x. Okay, and then on the other side, we've got negative x less than 4. Okay, now in this case, that's, remember when we're doing algebra, we never write in a 1, but we always have an imaginary 1 there if there's no number. So I'm just going to write it in blue. That's like negative 1 there and a negative 1 there. Okay, you don't have to write that in yours because you probably shouldn't. It's not actually good practice to write the 1 in at all. Okay, but what we're going to do is we're going to divide by negative 1. That means we can cancel that out. And I'm just going to do this all together actually. So we can divide by negative 1 on that side as well. That means we can cancel that out. Now remembering when we're dividing by a negative, that means that you flip the signs around. So in this case, we're going to have x. Now this is going to become the other direction, a greater than, not a less than. A less than, not a greater than. Okay, so we can say negative 2 divided by negative 1 is positive 2. Okay, so x is less than 2. Now on this side, again, that's going to flip around, so it's going to become a greater than sign. 4 divided by negative 1, and a positive divided by a negative is a negative. So we've got negative 4, and then x. Okay, now it's going to be a little bit tricky when we put this inequality together now, because again, the x goes in the middle, same as before. But x in this case is greater than negative 4, so that negative 4 That's the smallest number, so that should always go on the left-hand side. And then the bigger number, okay, that should go on the right-hand side, so 2. Now you should check to see whether this is right. Just check that the arrows are in the same direction as what you wrote them down as originally. So we've got that open side facing the x there, and you've got the open side there, the pointy end going towards the -4. And in this case, you've got, again, the open end facing the 2, which is there, and the pointing end going towards the x. So that's all good. All right. Okay, so from this, I want you to spend a bit of time doing a Google Form sheet for me. It's on that plan. Please get in touch if you have no idea what I'm talking about. And use GeoGebra as well. I think it's really handy to have that visualization so that you can check that you're doing things right. Oh, the last thing I probably should say as well, if we were going to represent this on a number line, okay, so say we'll start at -5. Because this is going to come up on the Google Forms that I want you to do, okay? Because you're, what I'm planning, I haven't actually made it yet, but what I'm planning is that I want you to look at the inequalities and then from that decide on which of the answers is correct, but on a number line. We'll see how that goes. Okay, so x is between -4 and 2. Okay, so and neither of those are equal to, so we use an open circle for both. Okay, so we have an open circle at 4, we have an open circle at 2, and then x could be any value between those two open circles. All right, and that's how we would represent it on a number line. Okay, like I said, have a go at the Google Forms sheet and get in touch with me if you've got any kind of immediate dramas. All right, thanks very much, guys. I'll talk to you on Thursday. Okay, bye.